Okay, guys, we're starting on page 4 today. Okay, is there anything on page 4 that looks familiar to you? Like somewhere around here? Yeah, we already did that, didn't we? Okay, so do you remember about natural numbers and whole numbers and integers and rational numbers and irrational numbers and all that kind of real number stuff? Okay, good. Like I said, when we made our graphic organizer, we may refer back to that every so often this year as we talk through numbers. Okay, so I also told you yesterday, or maybe I didn't, but if I didn't, we're going to pretend I did, that this is a brand new book. One of the reasons we picked this book over some of the other books is because of their examples. Okay, the examples that they give, the core concepts, these kind of topic kind of things, they're very, very good. Okay, very good examples. And so when you're doing homework from the book and maybe you're struggling or something, I wouldn't hesitate to recommend to you to look back at the examples. Okay, chances are there's an example somewhere that is something that we talked about or something that you need help with the bookwork. Okay, so here's the core concept that we're going to talk about today. Okay, what are we talking about today, by the way? So we're going to write domain, right? We're going to write domains today. Now, when we're talking about a number line, we're really only talking about one thing, right? And since it's a horizontal number line, we usually talk about that being the domain. But it is a little bit different than we did the other way, or the other day, only in the fact that this is just a number line, it's not a coordinate plane. Okay, we have already talked about domain this year when we talked about the parent functions. Okay, so we're just kind of scaling it back a little bit and only talking about one number line. All right. So this is the inequality. This is the interval notation. This is one of our vocabulary words today. We've got 2, so we're eventually going to go put that on a piece of paper that will eventually end up in the vocabulary section of your notebook. Okay, interval notation is our first one for today. Okay. Now I know there's 2 things that are highlighted here, and I think you guys are used to thinking, oh, the highlighted ones are the vocabulary words. Well, that's good. You still need to know what those are, but the ones we're specifically focusing on, the first one we're focusing on is interval notation. Okay. So if something goes from A to B, and that's what this is kind of saying, isn't it? X is between A and B. It's greater than A, but less than B. Did I say that right? Greater than A and less than B? What should it be? Greater than or equal to A, less than or equal to B. Does that really matter? Does it really make a difference? Absolutely. You'll see in a second. Okay? So if we're saying A is between X is between A and B, including A and B, this is what the interval notation looks like. Now, we did talk about something specifically like this the other day, didn't we? With the brackets. Yeah? So here's what the graph would look like. Okay? What do you notice about this graph compared to this graph? The circles are filled in. These circles are not filled in. So look back at the inequality and tell me the difference. One includes A and one doesn't. One includes B, one doesn't. This is greater than or equal to A. This is greater than A. So you remember a minute ago when I said, does it really make a difference? Now answer that question. Yes. Okay. Yes, it sure does. All right. Look at the difference in the interval notations. Brackets, parentheses. Okay. When things are included, like we talked about the other day, we use a bracket. When things are not included, we use a parenthesis. Okay. Does that make sense? Are we allowed to have one bracket and one parenthesis? Absolutely. Or one parenthesis and one bracket, right? Look at how the graph is compared to the inequality, compared to the interval notation. This is not a concept that's very hard, even though they call it a core concept. Why would they call it a core concept if it's not very hard? Because it's very important, right? It's very important. We've already, in fact, used interval notation. If we've already used interval notation, why are we talking about it again? Did we call it interval notation the last time we talked about it? I just said this is one way and this is another, right? We need to get that concept in our head. Now let's talk about the vocabulary and let's use the right words to talk about it. Okay? So that's why I'm not really going over this like really focused in one example at a time. I'm just saying here's 4 examples because like I said, we have already talked about this, but now we are using our correct vocabulary. Okay? So the first core concept that we're talking about today is building intervals on the number line that are in interval notation. Okay? This is the inequality that goes along with it. Look at the top of the next page. There's another core concept over there, isn't there? How is this different than the core concept we just talked about? Right, so it's going all the way, going all the way, going all the way, going all the way. Or everything, right? Okay, so these first examples had 2 stopping points. Or it approached 2 stopping points. Maybe it didn't quite get there, but it approached them. This one only has 1 point involved in it. Or in fact, no points, doesn't it? No specific points, I guess I should say. But we're still talking, focusing about interval notation. Remember how we talked about this is going to go to infinity? What sign are we always going to use on infinity? The parentheses, right? The parentheses, okay? And negative infinity, is there such thing? No, but we do it anyways to show we're talking about to the left, okay? Does that make sense to everyone? Yes? Okay. Turn the page real quick. Last core concept for this lesson is right here on this page, page 6. Set builder notation. Now, is that what we wrote the other day when we talked about set builder notation without calling it set builder notation? Or did we only write that part? We didn't write the first part, right? So is that confusing? When we talked about this the other day, and we said, let's just pretend here's a 2, and let's just say it's going all the way over here, right? How would we write that the other day? We said x is greater than or equal to 2, right? So the only thing that's added in this set builder notation is we're saying this. Okay? This is set builder notation. It's like correct, super correct set builder notation. We're telling ourselves we are talking about x. This vertical line is not a 1, it's a vertical line. And this vertical line means such that. So we're telling ourselves we're talking about x such that all the x's are greater than or equal to 2. That's all we wrote the other day. This is what we're going to make sure that we write correctly today. Can you tell that they mean the same thing? That's pretty self-explanatory, pretty easy to think about, right? But now you know what all the parts mean. All right? So just some real quick examples, because we already did one right there. But if we're on a number line and we're going from 1 to 6, like that, what would that look like in interval notation? That would be from 1 to 6, like that, right? How would it look in a set builder notation? We'd have the brackets, right? The pretty brackets. We're talking about x, such that, what's true about those numbers? It's between 1 and 6. What are the signs that go with it? It's greater than 1, less than or equal to 6. Perfect. Okay? So now I'm going to give you a really hard one. Now, I know when you guys first talked about number lines, you made the number line and you said zeros in the middle, and then you put evenly divided lines as possible all the way out to both directions. We're in Algebra 2 now. We can handle that. I don't even have a 0 on my number line. Could you put a 0 on my number line if I ask you to? Yes, I hope so, right? You would know it would be in between these two numbers, but closer to -2. So maybe like right here-ish. Okay? Are you okay without a 0 on there? Okay, good. So what if it looks like this? Yeah, those are colored in. I'm sorry, my coloring skills are poor this morning. Okay? What? So how would we write it in, well, how would we write it in interval notation? So you want to bracket? How far left is it going? To infinity? And then as it's coming this way, what's happening? Stops at 2, negative 2. Bracket. Why does it have to be or? Okay. Okay, then what? Questions? Sir? That was when we were talking about and. That's actually what I was just looking up. Okay, that's what I was looking in my book for right now. Because this is interval notation. What do you put there when you do this? Or? Okay. Okay. So this is, are we okay with this right now? I promise I'll go look it up today, and if it's something different, I'll fix it tomorrow for you. Fair enough? Okay? Because here's the deal. Does negative 3 work here? Like, is negative 3 part of my solution? Is it in the colored area? Okay? Colored in area is right here. Negative 3, right? Is negative 3 less than negative 2? Yes. Is negative 3 greater than 5? No. So it's kind of got to be an or. See what I'm saying? Okay? So this is interval notation. What about set builder notation? What does that look like? Pretty bracket, right? With x such that tell me about x. X is less than or equal to negative 2 or greater than or equal to 5. Done. I've got one here for this part and one here for this part. This whole line, remember, is the x-axis. It's like the x-axis. It's just a number line, so we're treating it like the x-axis. That's why we said today we're going to be talking about domain. We're going to be writing domain. Does that make sense? Any questions? You good? I think that's really all you need as far as instruction goes. The only difference is I gave you the number line and asked for what it would look like in interval notation and set builder notation. If I gave you interval notation or set builder notation, would you be able to draw a graph? I mean a number line, excuse me, thank you. Would you be able to do that? Do I need to do any examples of that for you? No, you got that? Okay, that was pretty firm. No. Okay, sorry. Any questions? Okay, just so we're clear, I know it's on the board, but just in case, you're doing page number 7. You're doing problems 3, 4, 7, 10 through 14, 17, 19, 21, 24, 25, and 31. So, remind me how I feel about homework. Am I going to give you busy work? No, I'm not going to give you busy work. And if I give you this many problems, what does that mean? It means I need you to do all of them. I'm not going to assign you problems I don't want you to do. But that means there's several different types of problems in this group. But I've given you what I think you need in order to grasp the concept. But not anymore. Okay? Any questions? Yes, sir. Yes, please put this as your title on the top of the page so you remember what problems to do. Okay? Any questions? Peace.